So we can also take these factoring methods and apply them to some real situations. Like this is example 2, again, can be found in our PowerPoint on Canvas. But a cryptographer needs to arrange 60 numbers in a rectangular array in which the number of columns is 2 more than twice the number of rows. So basically, we're going to have a rectangular array, and the number of rows, we don't know how many rows there are, so I'll just call it R, is two more than twice, sorry, the number of columns is 2 more than twice the number of rows. So 2 more than means 2 more than 2 is 4, 2 more than 6 is 8, 2 more than 10 is 12. So to get 2 more than, we'd have to add 2. And it says it's 2 more than twice the number of rows. Well, twice means 2 times. So it's 2 more than 2 times R. So we've got this rectangular array whose number of rows we've identified as R, and number of columns we've identified is 2R plus 2. And in that rectangular array, we have 60 numbers. And basically what that's giving us is the area of this rectangle. And the way we know we determine the area of a rectangle is by taking its length times its width. So if our area of this rectangle is 60, then that means that 60 must be equal to length times width, which would be number of rows times number of columns, or number of columns times number of rows. Either way is okay. And now we want to solve that equation. So, to do so, we of course are going to distribute the R to both of the things in the binomial. So R times 2R is 2R squared, and R times 2 is 2R. So we can see we've got a quadratic equation because it's got an R to the second power. And whenever we're solving a quadratic equation, we know we need to get it equal to 0. So to get this 60 to be 0, we'd have to subtract 60, but we'll have to do that from both sides. And when we do that, we'll have 0 is equal to 2R squared plus 2R minus 60. And now we want to solve that by factoring. So we know we always look for a greatest common factor first. Well, I can see that everything in this polynomial is divisible by 2. So I'm going to divide out a 2. If I divide 2R squared by 2, I get 1R squared. If I divide 2R by 2, I get 1R. And if I divide negative 60 by 2, I get negative 30. So step 1 is always to look for the greatest common factor. Step 2 is to look at this polynomial that we have in the parentheses and ask if it's a special case. All of our special cases that we've learned about so far have 2 terms. This has 3 terms, so it's not a special case. So we go on to the next step, and we notice, therefore, that this polynomial is quadratic, and it has a leading coefficient of 1. So these are easily factored by just unfoiling. We again know that first times first has to equal R squared. Well, that's why each of these binomials will lead with an R, because R times R is R squared. Now we know that we need to find 2 numbers when multiplied together equal negative 30. So again, that tells us one is going to be positive and the other is going to be negative. But when we add those 2 numbers, they add up to the coefficient of the middle term, which we know is a 1, because when you have a variable without a number in front, its coefficient is always 1. Thinking about the factors of 30, 1 and 30, 2 and 15, 3 and 10, 5 and 6, and one of those pairs, if one was negative and the other was positive, can add up to 1. And that's if we chose 5 and 6 and made the 5 negative. So we have one factor, r minus 5, and we have another factor, r plus 6. Now in this polynomial, again, we're taking it one step further and we're wanting to solve. In this polynomial, we have three things that are multiplied together that have a product of 0. 2, excuse me, r minus 5, and r plus 6. So if we set each of them equal to 0, we'd have 2 equals 0. Well, that's impossible, so we're not going to get a solution from that. We have r minus 5 is 0, and we have r plus 6 is 0. To solve the r minus 5 equals 0, of course, we'd have to add 5 to both sides, and we'd get r is equal to 5. To solve the r plus 6 equals 0, we'd have to subtract 6 from both sides, and we'd get r is equal to negative 6. But we've got to remember this r represents number of rows in this rectangular array. You can't have a negative number of rows. It's not practical. So that is not a solution. So now what we know is that r is 5. And if r is 5, then the number of columns would have to be 2r plus 2, we remember, which would be 2 times 5 plus 2. 2 times 5 is 10, and 10 plus 2 is 12. And therefore, we find that the number of rows in this rectangular array is 5. The number of columns in this rectangular array is 12. And if you check that by plugging it into the original equation, you're going to find it works. But also, think about the basis was that we're finding the area of a rectangle, length times width. 5 times 12 is 60, and that's what they told us our area was.